My name is Matt with the National Weather Service Chicago office located in Romeoville. I want to take these next couple minutes to talk about two of the more common weather variables that you may hear frequently reported, and those are humidity, in particular relative humidity, and dew point. Now, both of these variables are quantifying the amount of water vapor in the air, just in different ways. And water vapor is in all the air near the surface, and it originates from evaporation over bodies of water, transpiration over agricultural lands and forested and vegetation areas, and it's all key part of the global water cycle. Again, all air has some amount of water vapor in it, whether it be over land or water, or over urban areas versus over cropland and forested land. It all has some form of water vapor in it. We just, most of the times, cannot see it. First, relative humidity. This is a ratio, always expressed as a percentage, of the amount of water vapor that's in the air compared to what actually the air could hold if it was completely saturated. So that's a percentage. Dew point, on the other hand, is a temperature. And it's the temperature in which the air would become saturated if it was cooled to, given the amount of water vapor that's in there. So cooling that air mass, given the amount of water vapor that it would have, here's where it would eventually become saturated. That air mass can hold no more water vapor because it's cooled to it. So again, you can see that there are differences there. Better shown in an example. Let's take a look at an example, for instance, on a mild summer day. First here we're going to look at a single volume of air, a parcel of air, and we'll pretend we can see that suspended water vapor, such as in this example. So this mild summer morning, the temperature is 65. Now the dew point, that temperature in which the air would become saturated if cooled to, is 63 in this example. That gives a relative humidity of 94% in this particular example. Now if we jump to the afternoon here, the temperature 90 degrees, our dew point has actually come up to 67 degrees, but our humidity has plummeted to 47%. Now why exactly is that? Why did the humidity drop significantly? Well, again, if we remember, by the definition, that's a ratio, and what has happened is that amount of water vapor that the air can hold is directly related to the temperature, the thermal characteristics of that air mass. And the warmer the air, the greater amount of water vapor that it can hold. So in this summer afternoon example, when the temperature is warm to 90, it can hold exponentially more water vapor than could that morning volume of air that was only 65 degrees. So that has led to a sharp decrease in humidity. But the dew point has gone up. And again, that's more directly tied to the absolute quantity of water vapor in the air, and something we as people can more directly feel on those summer days. So the uncomfortability level has actually increased slightly, going from 63 to 67, even though the relative humidity has plummeted. So because relative humidity varies significantly based on temperature, again the denominator of that relative humidity equation, the dew point tends to be a more steady term and varies directly by how much moisture is in the air. Thus, for muggier weather in the warmer season, dew point can often be a better quantifying term. And also telling drier air in the spring or summer, dew point is usually a better term to understand than relative humidity. Now, relative humidity certainly has its uses in meteorology and beyond, but one of those for the public can be in the wintertime inside the home when that air is brought in from the outside. There's very little moisture in it, and it's warmed up. The humidity can be very low, and that, again, depending directly on temperature, that helps us to express the lack of moisture in the households in the wintertime. So there's one use of relative humidity. Do you know the Weather Service actually forecasts dew points and humidity? We of course forecast temperature, but we actually forecast the amount of moisture at the surface as well. On our web page, if you enter your zip code or location, or if you click on the map, you'll jump to your point-and-click forecast, we call it, and you'll see a lot of details for the next week of weather. But if you scroll down on that page, you'll see information on hourly weather graph and also tabular forecast. If you click any of that information, you'll see details on the hourly temperature, dew point, or humidity that we have forecast. So thank you for joining us in the Weather Service about humidity and dew point and what's the difference. Be sure to impress your friends or share on social media about the differences between humidity and dew point, and also feel free to like our Facebook page or follow us on Twitter.